Welcome to Data Engineers Academy. Yeah. Today we are going to know in this tutorial. I am going to show you a real hands-on way to cut Snowflake compute costs using materialized views. We will build a query that your dashboard might run dozens of times a day, measure what it costs as a regular view, then convert it into a materialized view and measure the difference. Along the way, we will hit two real time Snowflake errors, and I will explain exactly why they happen because they teach you something important about how Snowflake actually works under the hood. Let's get into that. Yeah, if you see here, mm, our agenda is here's the roadmap. First, we will cover how Snowflake billing actually works, credits pricing, and where your money goes. Okay, and in second, the optimization levers organized from basic to expert, so you know what to tackle first. Okay, and next third, and this is the core of the talk, a real case study, a regular view versus a materialized view, including two genuine errors I hit and how I fixed them. And finally, we will wrap up with results and the key takeaways you can apply immediately. And here in slide 3, you can see that the formula for dollar cost is credit consumed into price per credit. Okay, let's start with single most important formula, like dollar cost is credits consumed into price per credit. Credits consumed is driven purely by warehouse size and how long it runs. Okay, warehouse size and how long it runs. A medium warehouse always burns 4 credits an hour, whether you are on standard edition or business critical edition. That number doesn't change. Okay, price per credit is the other half. Okay, it is the other half that's driven by your Snowflake edition and your cloud region. Standard is cheapest, enterprise costs more per credit, business critical costs more still, and region matters too. The same edition can cost more in one region than another. And so remember, sizing and auto suspend control the first variable, edition and region choice control the second. They are independent levers. And when we go to slide 4, you can see here uh, 4 cost buckets, right? Yeah, compute is the big one. Usually 70 to 80% or more of your total spend. This is your warehouses running queries, loads, and transformation build per second within a 60-second minimum. Storage is usually small. This is your tables, time travel history, and fail-safe copies built at a flat rate per terabyte per month. And importantly, the rate is the same across every edition. Cloud services is mostly invisible. It's free as long as it stays under 10% of your daily compute. Okay, most accounts never notice this bucket. And then there's a serverless. This is the one people miss. Okay, snowpipe tasks, auto clustering, search optimization, these all build independently of any warehouse. Okay, it is independent of any warehouse. If you only audit your warehouses, you can completely miss this piece of the bill. This means here snowpipe tasks, auto clustering, and such optimization can include in bill. And next, when we go to Slide 5. Here's how I like to organize the actual optimization work. Four levels. In level 1, basic is just understanding the bill, warehouses per second billing, and the fact that idle warehouses cost you money for nothing. And in level 2, intermediate, is about removing obvious waste, auto suspend settings, multi-cluster configuration, and resource monitors as a safety net. And in level 3, advanced, okay, it is advanced level, is where we tune things: query profiling, clustering keys, transient tables, and materialized views, etc. And next, here what is exactly what our case study today is about, level 3. And in level 4, it is expert level. It is governance and automation, tagging for cost attribution, budgets, anomaly detection, and a showback report, etc. And when we go to level, sorry, slide 6, here is a quick but important distinction before we move into the case study: scaling up versus scaling out. People confuse these constantly, and using the wrong one wastes money without solving your actual problem. Scaling up means increasing warehouse, extra small to small, and small to medium, and so on. This makes one query run faster, doubling the size, roughly half the time for a single heavy query. That means the time for running of your query will decrease by increasing the warehouse size. Use this when one query or job is just too slow. You scale up. And coming to scale out, it means multi-cluster, adding more clusters of the same size. This does not make any individual query faster. What it does is let more queries run at the same time without queuing behind each other. Use this when you have got many users or dashboards hitting the warehouses simultaneously. uh, and coming to the next slide. Yeah, here the regular views versus materialized views. All right, let's get into the actual case study. This is where we go from theory to something I actually built and ran. The scenario is, imagine a dashboard that repeatedly asks the same question: total order value and order count, broken down by customer nation. Okay, that requires joining three tables from Snowflake's built-in TPCH sample data. I will show in Snowflake Snow site. Mm, Here's what we are going to do step by step: copy the sample shared data into our own schema, build a baseline regular view with join, convert it into materialized view, and compare the compute cost before and after. Okay, simple plan. But as you all see, we hit two real roadblocks along the way, and those roadblocks start me more than I if everything had just worked on the first try. Yeah. Next, when we go to slide 8, we can see here. Here's the full build flow visually. We start with Snowflake shared sample data. That's a read only. We copy it into local tables. Okay, we copy it into local tables. Then we flatten the join into a single denormalized table. And finally, we build the materialized view on top of that. Now notice the two red boxes. The two, yeah, here the two red boxes. These are the two real errors I hit uh, between steps 1 and 2. You can't create a view directly on a Snowflake share because you don't own that storage. The fix is simply copy the table locally first into your newly created table as select. Okay. Next, between steps 3 and 4, materialized views only allow exactly one base table. No joins allowed in materialized views. Remember these. So the fix there is to denormalize first, physically flatten the join into a single table and then materialize it on top of that single table. Okay, materialized on top of that single table. We are going to look at both of these errors in detail on the next two slides. Okay, in slide 9, we can see that error number 1, I will clear it in Snowflake snow site, and also error number 2, I will clearly explain you there. And here we can see regular view versus materialized view. Mm, on first query, both costs roughly the same. We will see in the snowflake side this also. Just here see the difference. First query, full compute cost in materialized view also. uh, Repeat queries, full compute cost every time, because it computes the whole query. That means the if you perform three joins on the query, it will recompute it. Okay, it is near instant minimal compute. Extra or ongoing cost none. Storage plus background refresh. Here cost will be applied because on the materialized view, and table constraint any number of joins uh, we can perform in regular view, but in materialized view only one base table. Here no join is allowed, and best fit rarely queried aggregations, expensive frequently read or slowly changing data. And if you see in slide 12, this is the chart illustrates the pattern we just described. The red line is the regular view. Notice it climbs steadily because every single query adds another full unit of compute cost. The green line is the materialized view. It pays the initial cost once and then barely moves because every additional read after that is nearly free. Okay, and next here what this exist status shares and read only. Materialized views allow exactly one table. Denormalized tables need refresh logic. Query history has latency. A cleanup after experiments. Here the key takeaways from this session. You can read these ones. Okay, now let's move on to Snowflake. Here I am creating a new database and schema in my worksheet. Just run this. As I actually created, it will be showing like successfully created. My database is successfully created. My database name is cost demo db. Okay, and next I'm creating a schema cost demo in this database. My schema name is tpch, and yeah, let's create the schema. Yes, successfully created. And then use I'm using my database, and I am using my, here you can see I am presently in public schema. Now I am using TPCH schema. Okay, you can see here it has changed, and I am creating one warehouse. Yeah, it was successfully created. This gives us a This gives us a clean database and schema just for this exercise. I'm using this, and I'm using the warehouse demo warehouse. I'm just giving a name. You can give whatever you want. I'm giving demo warehouse, and I'm using this warehouse. Here you can see the auto suspend is 60 and auto resume is true. Here it is not just a syntax. Auto suspend 60 means this warehouse turns itself off 60 seconds after it's got idle. So we are not paying for compute we are not using. And here we are auto resuming is true. Means it turns itself back on the instant we run query. That means let's repeat again. If we are not using warehouse after 60 seconds, it automatically suspended. If we run a query after for suppose after 5 minutes or 10 minutes, and it is automatically resuming the warehouse. And initially suspended true means just means it does not start burning credits the second we create it. So, and next. Here, Snowflake ships every account with a free sample data set called Snowflake Sample Data. It's a TPCH benchmark data set. Um, Here we can see what is it. Basically, a fake but realistic order and customer data. I want to use the orders, customer, and nation tables from it. But here's the catch. The simple data is what's called a snowflake share. It's read only. We don't own that storage. So we can't build views directly on top of it. So the first thing we do is copy what we need into our own schema. Here since I'm going to work on orders table, customer table, and nation table, I'm going to copy that. Okay, I'm going to copy that into my schema. For example, if you see here, if we download install Snowflake, you can see here, like if we go to catalog and table explorer, these are the it is the default database we can access. For example, if we go this, I'm going to that. So as I am taking the sample of TPCHSF10, and here there are so many tables like 1, 2, 3, 4, 5, 6, 7, 8 tables are available, and from here I am going to use customer, order, and nation. Yeah, if we go to schema, you can see here, sorry, in TP10 tables. In tables, we can see what are the tables we have: customer, line item, nation, orders, parts up, region, supplier, etc. So now I am taking customer, nation, and orders. Okay, by clicking on that, just if you want to see the data, click here, data preview. So we can see here 1.5 million rows are there here. Likewise, the orders nation table data preview. If I want to see just what are the columns they have and orders. Okay, orders order table have columns order o underscore order key, cust key, order status, total price, etc. So from these tables, I'm copying these tables into my schema. So for that I'm creating a table here named orders. Okay, table order successfully created, and I am now going to create customer table, and next nation table. Okay, These are successfully created. And next, we will going to create a view. Now let's imagine a dashboard that asks the same question over and over. Give me total order value and order count broken down by customer nation. That means joining three tables. Let's build that as a normal SQL view first. Okay. As I was asked to give total like order count, total order value, average value. I'm joining these three tables using this SQL query. Okay, I'm going to create this view. It is successfully created, and now I'm going to run this statement and this query. If you see here, I got the order count, total order value, average order value, right? Because I asked for four columns, right? Nation, order count, total order value, and average order value. Okay, let's let's run this. Yeah, you can see here. I have run the query. Select query test. Total elapsed time. It takes 2512 2512 seconds. Just a minute. I'm going to run it again. Run it for three times continuously. Now run this. Actually, here I am using the Snowflake account usage query history and information schema query history. You may not get here the result immediately. It will take maybe 40 minutes or 1 hour, etc. But it won't take. The difference between this is that's the account usage version can take up to 45 minutes to populate because it's built for long term reporting, okay, not live debugging. But information schema gives us near real time results, which is what we want right now. Okay, if I run this, you can see we can see here I have run this three times. I have run this previously, but it is taking more time. Neglect this. Just see this. Okay, I have run this query for three times, right? So you can see that it takes 301, 239, and 101. Okay, and next, remember this cost one. That means and also the total elapsed time. I will tell you why this later. And next, run this. Just I'm creating a materialized view. You can see here an error. I already said right, I have encountered an error. Materialized view definition. What I told you is in materialized view definition, no joining is allowed. Okay. So what I have to do is first denormalize that. That means we are going to create a flattened table first from this join from using joins. Okay, let's see that I'm creating or replace a table orders denormalized. I'm creating a table name it orders denormalized. I'm selecting the order key, total price, order date, customer nation. I have already three tables, right? From there I am creating a table. Yeah, it is successfully created. Now using this table, okay, or this denormalized table, I am going to create a materialized view. Name it nation order summary materialized view MV. Okay, as select, I am selecting nation, count of customer order key, and sum of total price and average of total price. From which table I am bringing that from orders denormalized. Group by nation. So I am now going to create a materialized view. It's creating, yeah, it was successfully created. Um, denormalized table is just a physical pre-joined copy of the data, not the materialized view. Here we have created the materialized view. Like here, we are only referencing one table, right? And next, I'm going to run a table, just right, select. Let's run this query for three times again. Okay. Now I'm going to see the time. I have to save time, right? Let copy this. But here my view name is different, right? Nation order summary. Let's run this. Yeah, you can see here. For the first time, it takes 809 and next 80 and next 153. Compared to normal views, regularized views, materialized views favors us best to compute fast. Okay, let's see for example. Let's wait. I will show you detailedly. Now, if you see this is our normalized view result. you can see, for example, it takes 8150 milliseconds, 7910 and 8420. Okay, it is our normalized view total elapsed time. And next, if we see materialized view total elapsed time, yeah, when we see the materialized view, just a minute, yeah, here we get like this. The total elapsed time is 310 milliseconds, 290 milliseconds, 340 milliseconds for the same query. Here it is taking less time compared to normalized view, right? Notice this. And here is the difference, like materialized view is useful than normalized view. And if you want to see the how total credits consumed, you run this statement. Uh, it will show like as it is taking time. I have created, just I have taken a screenshot of this, and here it is. uh, Refresh start time and refresh end time. If any new data is added to the to our tables, it will be refreshed and give us the updated data. So here the refresh time is 10 hours, like morning 10 to am and 3 seconds, and the end time at 11 seconds, and the total credits consumed are 0.0021. This how, like, this is the way we can reduce our credits to charge, like we can avoid the charging on us. Now drop the materialized view. Does not exist. That means I have already dropped that, so it is showing like that. So you have to drop all these things. That drops every object we created and suspends the warehouse. And that's the full exercise, from a slow repeatedly recomputed view to a materialized view that pays once and serves fast reads after that, with two genuine snowflake constraints explained along the way. Yeah, this is the session. I think you will like it, and try it on your own. I will be dropping this in my GitHub link. I will give in my description. Okay, thank you. Do subscribe to the channel and like the video. Thank you.